10. Scroll down to page 10, please. So it says interpretation. So we're getting closer to the lesson, okay? So the average of f of x, so the average of any function is 1 over b minus a, integral from a to b f of x dx. Yes? So I'm just giving some interpretation. So whenever you see that phrase, average of, write it down. Now we're doing backwards. Copy it on the expression. So if you see this expression, that should just remind you of what are we finding?
Average.
The average of f of x. Oops. Over
A to B.
the interval a to b. So I'm doing interpretations. So if you see that expression, you need to say, hey, that's average of f of x. This is that function, nothing more, from a to b. Okay, now you're learning something brand new. We're doing more interpretations. Write this down, please. If you see the phrase change in, or sometimes the AP will say net change. So you're learning something brand new. So if you see net change or change in, what does the word change mean? If I say, what's the change in temperature? What simple operation will you do?
Subtraction.
Subtraction, thank you. So it's nothing but f of b minus f of a. Is that clear? Is everybody okay with that idea? The word change means difference. So you could also say difference in. But the word they will use in calculus is change. So that, copied on the last one, if you're given f of b minus f of a, that's nothing but the
net change
in
f of x
of f of x.
A, comma b.
Okay. From. Oops. I'm still getting used to this new system. From or over a to b.
Yes.
Is everybody okay there? I want you to memorize this. So in other words, anytime you see a difference in your mind, you're saying that's the change in. Is that clear?
Yes.
Okay, memorize those 4 ideas. So if you see average of, it's nothing but the average formula. If you see the average formula, this is the average of f of x. Then, if you see net change or change in, it means f of b minus f of a, backwards. And then if you see f of b minus f of a, hey, that's nothing but the change in f of x. Okay, let's move on. So next page basically goes over, just put your pencils down. So just interpretations. So if you see change in, it's f of b minus f of a. If you see f of b minus f of a, it's change in f of x over a to b. And then from the first semester is average rate of change, nothing but m sec.
Yes.
Okay, that's f of b minus f of a over b minus a. And if you see f of b minus f of a over b minus a, that's average rate of change of f of x. Everybody okay there?
Yes.
Okay. And then finally, if you see average of, then it's the 1 over b minus a formula. And if you see the 1 over b minus a formula, it's the average of. Okay. So let's just do a couple of simple examples. We're on page 12. Okay, just copy it on the function. You don't need to copy it on the English. So it says if a of t denotes the
Acceleration.
acceleration of the particle, find the
Average acceleration.
So is that just average of the acceleration function?
Yes.
So is that just AB equals 1 over, I'm just applying the average formula. 1 over
Pi over 2.
pi over 2. Integral from
0 to pi over 2.
For a of t, yes? It's the average of acceleration. Nothing clever, nothing clever. I'm just plugging it in. Next step. What's 1 over pi over 2?
2 over pi.
Is that 2 over pi? Oops. 0 to pi over 2. Is that just that function? 2 cos 3t minus et dt. Is everybody okay there? Next step, look down. I'm walking you through. Look down. 2 pi. Oops, 2 over pi. 2. Okay, stop. Is that cos t or cos monkey?
Cos
monkey.
Okay, so who remembers what the integral of cos monkey is?
Sine 3t
Sine
over
monkey.
3.
Okay, one second.
Sine monkey, yeah.
Okay, there you go. So is that sine
3t
3t
divided
over
by
3
yes.
minus et? Is everybody okay there? Lower limit,
0.
upper
0.
limit.
Pi
Pi
over
over
2.
2.
Okay, stop. Can we go? Can we leave? Is that good to go? Is that now a basic problem?
Yeah.
Yes.
Okay. So I'm just showing you how to set it up. Okay. If you attend office hours, I will do this, but otherwise we're kind of good to go. Okay, let's do another one. We're on page 14. Copied on the function. We're on page 14. Copied on the function. It says if P of t denotes the
Population of a town.
population of a town in
Thousands.
thousands, keep track of that, at time t in years, find and interpret 1 over t integral 1 to 3 P of t dt. Okay, specifying units. So relax. So it's 1 over 2 integral 1 to 3. Is P of t given to us? Can we just plug it in? Yes?
Yes.
Look down, look down. I'm walking you through it. Okay, formula review. What's the integral of 1 over t?
Ln absolute value.
Ln absolute value of t. Very good.
Yes.
What careful? Is that sine t or sine monkey?
Sine monkey.
Sine monkey.
Sine monkey. What's the integral of sine monkey?
Negative
Cos monkey.
Negative cos pi t over.
pi.
Oops. Okay, where's the undo button? It's getting tedious. There must be a quick thing for undo.
I think
Okay.
it's at the bottom left.
Uh,
You see there?
Yeah. The
oh,
bottom.
there. Yeah, there. Okay, yes, thank you. Over pi, correct?
Mm-hmm.
And then lower limit 1, upper limit 3, yes?
Yes.
So equals, is that just ln 3 minus 1 over pi cos 3 pi
Mm-hmm.
minus parentheses ln
1, 0.
1 minus 1 over pi cos pi? Yes?
Yes.
You don't need to look at the board,
Yes.
just look down. Okay, let's simplify. 1 over 2 ln 3. Okay, now I'm doing this so I don't hold the class back. Cos 3 pi is cos pi, which is negative 1. Okay. Okay, I'm not spending time doing the trig. Minus, who remembers what's ln of 1?
0.
0. And then cos pi is also negative 1.
Mm-hmm.
Can we open this up? Look
Yes.
down, look down. So ln 3, what does the second term become? Look down.
Plus
Plus 1 over pi.
Plus 1 over pi.
Minus
And then inside, is that positive 1 over pi or negative 1 over pi? Hint,
negative.
there are 3 negatives.
Negative.
1 over pi.
Negative 1 over pi. And will the pi 1 over pi's cancel?
Yes.
Yes.
Okay. So your final answer is ln 3 over 2. Okay, the question also says interpret. So go back to the original question. What does that expression remind you of? I will give you 3 phrases. Choose wisely. Do not speak. Do not speak. This is important on your homework. Is that the net change in the population? Is that the average rate of change of the population? Or is that the average of the population?
Average of the
Average.
population.
Is that basically 1 over b minus a integral formula?
Mm-hmm.
So let's write it down. It's that easy. So denotes the average population, because that's the average formula of the town. Careful, in thousands, correct?
Yes.
And guys, make up a unit. What would the unit of, say, average age be? What would the units of average age of kids be? Make up a unit that makes sense.
Years.
Kids.
15
Years.
years. So what do the average population units just be? Will that just be thousands and we're good? That's
Yeah.
it? Like, how is population measured? So it's just that units. So just in thousands. That's it. Oh, by the way, over, is that from 1 to 3?
Yes.
Okay. So you need to mention this interpretation plus that interpretation. Over the years, 1 to 3. And that's how easy that problem was. Okay, go to page 15, please. Same question, but this time it says find.
That change.
Very smart. Oh, by the way, it says they give you P of t and they say P of 3/2 minus P of 1/2. Is there any, do we find, I'll give you 3 options, choose wisely. Guys, this is not a trick question. It is not a trick question. Should I find MSEC? Should I integrate? Or should I just plug it in? Do not speak. It says find P of 3/2 minus P of 1/2. Which of those 3 operations I should simply do? Does it require integration? Should I
No.
do MSEC or should I just plug it in?
Plug it in.
Plug
Plug
in.
it in.
Just plug it in. Nothing clever. Nothing clever. So should I first find P of 3/2?
Mm-hmm.
Okay.
2 over 3.
Okay, very smart. What's 1 over 3/2? Will that become 2 over 3?
2 or 3.
Okay. And then plus sine of
3.
3 pi over 2.
Yes.
Yes.
Okay. Is everybody okay there? And then, guys, I'm doing the trig in my head so we can accelerate. That's 2/3 minus 1, by the way. Sine 3 pi over 2 is -1. Can we use the fraction trick?
Mm-hmm.
Yes.
Is that -1/3?
Yes.
Okay. What else should we do next?
Plug in 1/2.
Thank you. Plug in 1/2. Look down. Look down. What's 1 divided by 1/2?
2.
2. You'll just find the reciprocal. Plus sine
Pi over 2.
pi over 2. Very good. 1/2 pi. Sine pi over 2 is 1, guys. So what does it become?
3.
3.
3. What do we do last step? Read the question. What do we do last step? What do we do with these 2 guys? Subtract. So show the left-hand side. So P of 3/2 minus P of 1/2. Show the left-hand side. Is that just -1/3 minus 3?
Yes.
Yes.
Can we use the fraction trick?
Mm-hmm.
Use it. Tell me what you get.
Negative
10 over 3.
-10 over 3. Okay. Now the question also says, and interpret your result. So look at the left-hand side. It says P of 3/2 minus P of 1/2. I'll give you 3 options. Choose wisely. Do not speak for the 10 seconds. Is that the average of P of t? Is that the average rate of change of P of t? Or is that just the net change in P of t?
Net.
The net change.
Net change, remember, there are formulas you have to memorize. So the interpretation of that is, write this down, it is a net change in the population
Mm-hmm.
of the town over 1/2 to 3/2 years. Oh, by the way, population of the town in thousands, correct?
Yes.
Units. Nothing clever. Is a change in population. So it gets the population units. Population measured in thousands. That's it. Okay, I'm accepting questions, clarifications. You can say, Rama, I'm lost. Rama, I don't get any of this. I will not scold you. I will not shame you. Anybody? Miss Flores, talk to me. How are you doing? Flores, how are you doing?
I'm doing good.
Okay. All right. Now, this is just more of the same. Next, go to page 17, please. We're learning something new. Mode and motion. It says displacement of an object. Now, it's a new term, and I want you to memorize it. Those of you in physics will be able to make a connection, but it's not a big deal. Now, the displacement of an object is defined this way. This is the definition. There's nothing to argue. It's basically defined as the change in position of the object. Oops. Okay, over, say, T1 to T2. Oh, some of you are very bright. Is that the net change in position? So what does the phrase net change in position remind you of? Is that average formula or average rate of change formula or just difference?
Difference.
Difference. Someone write something else on the board, look at the board and say, I get it. Is that just S of T2 minus S of T1 because it's position? Is everybody okay with that?
Yeah.
From first semester, position is S. It's a change in position or net change in position. Now there's a difference. Okay, now I'm going to tell you another formula. Now you may say, Rama, where's the integrals coming? That's just change it. Okay, I'm going to give you a formula, and the formula makes sense 10 minutes down the line. Now the net change in position is also the integral from T1 to T2 of the velocity function. And I want you to put this in a box. Is the integral of the velocity function. So displacement, I want you to memorize it, is the integral of the velocity function.
Oh.
Again, stare at the board, memorize it. So I'm doing a review. So if you see the word displacement, you need to memorize that's the change in position. That's number one. Change in position means S of T2 minus S of T1. And you may say, where's the integral? It's the integral of velocity, the next guy. Okay, now let's do an example. So have a look at the example on that same page. It says find the displacement of the object from 0 to pi if v of t equals 3 sine t2 minus. Okay, I'm seeing who's already memorized it. So right on the left side, which is displacement, I need a left-hand side always. Okay, we just went over it. What's the formula for displacement again?
Integral.
The integral
Integral
of the velocity
Of
function.
0 to pi of the velocity function, yes?
Yes.
And have they given us a velocity function?
Yes.
Is that now a stupid problem? Okay, we'll just do one more step and then leave. Look down, 3. Okay, what's the integral of sine t?
Negative
Cosine.
sine.
Negative cos t. What's the integral of 2?
Negative 2t.
Negative 2t.
Negative 2t. Lower limit,
0. Pi.
0.
upper limit.
Pi.
Pi.
Is that now a stupid problem?
Yes.
Is everybody okay there? Now it's just evaluating a definite integral. Do not skip steps. Show every step on your homework, guys. So once again, displacement is the change in position, integral of the velocity function. Is that clear? Okay, let's do another example. We'll skip this. We're on page 19. Okay, it says find the
Change in position.
change in position. So smart kids, those of you making connections. So what are they asking for indirectly?
Displacement.
Displacement. Very good. Change in position, nothing but displacement. Make that connection. And so we can do a formula review. Is that basically S of 2 pi minus S of pi over 2, change in position? Yes?
Yes.
And is that nothing but the integral of the velocity function?
Yes.
Have they given us a velocity function?
2 cos t minus 3 dt.
Is everybody okay then? The more things you do yourself, the better off you'll be. Is that easy to integrate and plug in upper limit, lower limit? Yes.
Yes.
Okay, let's move on. Okay, next page. We're on page 20. Again, I'm forcing you to make connections. It says find S of 2 minus S of 1. Hey, smart kids. So what is that indirectly?
The
The displacement from 1 to 2.
Or you can also say it is the net change in
position.
position. It's S. Okay, interpret literally. So it says interpret your result. We'll do that in just a second. So it is the method 1. It is the net change in position. Okay, that's S. You don't have to overthink it. It's S of 2 minus S of 1. So the change in position of the object over 1 to 2. Or it is also the
integral of the
no.
velocity.
No, we're still doing interpretations. Or it is the
Displacement.
displacement. Thank you. It is the displacement of the object. I will accept both on your homework. Over 1 to 2. Yes.
Yes.
And so we have to find it. Is that just integral from 1 to 2 of 1 over t square minus et dt? We'll just do the next step so you get integrals review. Who remembers the formula? What's the integral of 1 over t square?
Negative 1 over t.
Very good. Negative 1 over t. 1 over x squared is negative 1 over x. So negative 1 over x minus integral of et.
Et.
Et. Oh, sorry, that's 1 over x. I mean 1 over t. Lower limit.
1.
1.
Upper limit.
2.
2.
Let's actually do this. So it's negative 1/2 minus, look down,
Square.
E squared.
e squared, look down, you'll be faster, minus parentheses, negative
1.
1
1.
minus
E to the power
E.
1.
e, e to the power 1.
Yeah.
Can we open that up? So negative 1/2 minus e squared
Plus
Plus
1.
1.
plus 1
E.
plus e. And can we combine like terms here using the fraction trick? So absolute final answer, is that just 1/2 minus e squared plus e?
Yeah, it's correct.
Yes?
Mhm.
Is everybody okay there? Okay, now we're doing, now this is the main part of the lesson. Okay, for the next half an hour. So I ran out of time because of the stupid computer, this thing. Okay, so write down today's lesson. So today's lesson, the big part of today's lesson is something called net change theorem. Okay, so I'm letting you know this is challenging. And since we lost time, I strongly encourage students to attend office hours. I cannot mandate it. I cannot force you to, but it's for your own sakes. Otherwise, you'll be lost on the homework. Understand that really, really well. You're very likely to be lost on the homework if you choose not to attend office hours or watch the video. So it's called the net change theorem. So write this down, please. So it says if f of x equals e to the power of 2x, find the value of that. Okay, just look at the board. Okay, look at that expression. I'm going to say something profound. Think about it. First, we need to find the derivative, correct?
Yes.
And then I need to find the.
Integral.
Wait a second.
Answer.
If I find the derivative and then the integral, what will you just end up with?
F of x?
F of x.
Yes.
Is that common sense?
Yes.
Okay, I'm going to use different language. You can make connections faster. So first we're finding the derivative and then we're finding the antiderivative. Will you end up at the same spot?
Yes.
Does that make common sense, intuitive sense?
Yeah.
So what's this? So you will end up with f of x, and then should we just plug in the upper limit, which is 3, and upper lower limit, which is 2?
Yes.
Yes.
Does everybody understand the concept?
Mm-hmm.
You're finding the integral of a derivative, which is the function itself. So final answer, Is that just f of 3 minus f of 2?
Yes.
Is everybody okay there? And now I can plug it in the function. F of 3, remember they gave you, is that e to the power of
6.
6 minus f of 2, which is e to the power of
4.
4.
That's it. And that's called the net change theorem. So the net change theorem says, so copy down the formula. It says if you have the integral of a derivative, so keep in mind, you're finding the definite integral of a derivative. And that is the bulk of today's lesson. If you're finding the definite integral of a derivative, it's nothing but f of x. But then you evaluate it a and b. So it says if you have integral a to b, copied on the formula, f dash of x. I'm going to write the right-hand side. So it's now obvious from our lecture. Is that just f of b minus f of a? Is everybody okay there? Because integral of a derivative is just a function, and then plug in the upper limit, plug in the lower limit. So that's called the definite integral. Sorry, net change theorem. So memorize that phrase. It's called the net change theorem. Okay. So I will say, what do we apply? You'll say net change theorem. Is that clear? Now have a look at the bottom. It says f of b minus f of a. I'm going to go backwards. See if you're okay with it. I'm going to write it backwards. Look at the board and say, oh, I get it. I get it. Is that working backwards? Integral from a to b f dash of x.
F of x, d of x.
Okay, I just went backwards, guys. I just went backwards. Now, here's what the weak kids do. Here's what the weak kids do. Look at the board, please. I'm making this clear. This is incorrect. F of b minus f of a. Here's what weak kids do on day one. No. Which formula is this? F of b minus f of a is just integral from a to b. I would have told you there is no formula like that. Okay, there is nothing we have learned. A to b f of x dx is nothing but f of b minus f of a. No, you must have the derivative. Kids forget the derivative. Okay. So I want you to memorize that pattern. Look at the top, look at the bottom, and memorize that pattern. When do you use the net change theorem? When you're finding the definite integral of a derivative. Is that clear? Because a common error, common confusion on day one is, Rama, when do we do this? And I'm letting you know when you only when you see the definite integral of a derivative. Is that clear? Okay, the next thing is something called the net change theorem corollary. Okay, write that down. Again, it's an English word that's pronounced corollary. The word corollary just means consequence. Oops. And here's what the net change theorem corollary says. Pay close attention. Now remember, so I'll write something on the board, play along, okay? Just play along. Okay. So is f of x minus f of a equals integral from, what's your lower limit?
A to x.
A, upper limit?
X.
X. Again, the positive guy. Draw arrows so you can see connections. So the positive guy is on top, the negative guy is on the bottom, correct?
Yes.
And then think before you answer. What am I writing? Am I writing F or am I writing F dash?
F dash.
F dash, is that clear? Don't forget the operator dx. Is everybody okay there?
Yes.
And then last step, pay close attention. I will add f of a to both sides. I will solve for f of x. So f of x equals, can I write f of a on the right side? I'm moving f of a to the other side. So I'm adding f of a to both sides. Plus integral from a to x, f dash of x dx. Again, I just added this to both sides and moved it in the front. Put this in a box, and that's called the net change theorem corollary. Now, intelligence is observing patterns. So observe the pattern. Smart kids, observe the pattern. A is in the bottom, X is on the top. Okay, let's do some examples so you get a feel for this. Let's do some examples. So if I say, I'm just making this up, v of 3, okay, I'm changing letters, minus v of 1 equals, okay, who can tell me the right-hand side?
1 to 3.
Integral
Integral
3.
from 1 to 3,
1 to
capital,
Should
f
have
V
dash
dash.
of t.
thank you, v dash
V dash. Oh.
of t dt.
Can we
Is
fit?
everybody okay there?
Mm-hmm.
Yes.
Okay, I'm just playing with your minds. Okay, let's do another one. Say I say 1 to 5 a of t dt. Okay, stop. I'm making sure students understand the lecture. Can I use the net change theorem right now, or I cannot use it? I'm making sure you understand it. In case you say, Rama, I don't know, I'm already lost. I can use the net change theorem only if I have an integral of a derivative. So I'm just letting you know. So I'm asking you the simple question right now, right now. It's like this, 1 to 5 f of x dx. Can I use the net change theorem? Yes or no?
No.
No.
No, I cannot use it. I cannot use it. Now, smart kids, now pay close attention to the lecture. This is today's lesson. Can I write a of t as
V dash of
V
t.
dash of
b
t.
dash of t? Very smart. And I'm introducing a derivative. Do you see that? Now can I use the net change theorem?
Yes.
Yeah.
So what am I writing on the right-hand side? I want to see if you understood the lecture. What am I writing on the right-hand side?
V of 5.
V of 5
Minus V of
minus V of 1. Ah! Did everybody understand that? Now that is key for today's lesson. The students that don't get this will struggle on the homework. So when the problem began live, you're saying, man, that's just, I can't use net change. Is this in 1 to 5 of acceleration? But I can write acceleration as V dash and then apply the net change. Let me do another example. Say 0 to 6. Okay, simple question to the class. The way it is written now, can I apply net change theorem? Yes or no? The way it is written just like that. Yes or no?
No.
No. However, I can write V of t as
S dash of t.
S dash of t. Now can I apply the net change theorem?
Yes. S of 6
Okay.
minus S of 0.
Is that S of 6 minus?
S is 0.
Yeah.
Okay, crazy smart kids. What do we know the integral of velocity to be? What's one interpretation?
Huh?
We did it 10 minutes ago.
Oh.
Displacement.
Displacement.
Yeah.
And what does this guy remind you of on the right-hand side? It is the
Change
Net-
of
net change in
position.
position. There you go, making connections. So it is the net change in position or displacement. You cannot forget what we learned 20 minutes ago of the object. Okay, now this is super important. Now your question to me would be, Rama, I'm still a little confused. Everybody, put your pencils down. Put your pencils down. So I'm doing a very important review. So put your pencils down. Look at the board, please. So your question to me will be, Rama, I'm still a little fuzzy. How do I know I should use the net change theorem? Okay. So for the next 20 minutes, I will use the word mismatch. Okay. So play along. Just right now, just play along. If there is a mismatch, you will use the net change theorem. If there is no mismatch, you will not use the net change theorem. Relax. In just 2 minutes, I'll tell you what I mean by mismatch. Is that clear? But I want you to remember this. When you see a problem, the first question you should ask yourself is this: is there a mismatch? If there is no mismatch, then there is no reason to use a net change theorem. But on the other hand, if there is a mismatch, then you will use a net change theorem. I'll now copy down this problem on page 23, and I will explain the concept of mismatch. Copy down that on page 23. Okay, now look at the board. Look here, and then look here. Do those two exactly match, or there's a mismatch?
There's a mismatch.
Does everybody understand they do not match up? One is f dash and the other is f. Did everybody understand that?
Yes.
Does everybody get it? That two different ideas. So my rule is, if there is a mismatch, you will use the net change theorem. Hey, smart kids. So what can you write for this guy?
F of 3 minus.
Very
F,
smart. F of 3 minus
F of
F
negative
of
1.
negative
f of -1. There you go. If there's a mismatch, I'm applying the net change theorem. Okay. Now, have they given us f of x? Can I just plug it into the function?
Yes.
Yes.
Is everybody okay there? By the way, now look at this guy. Now, here's another question that weak kids have. I'm not scolding anybody or shaming anybody when I say weak kids, but I'm just telling you confusions that arise on your homework. When I'm finding this, look at me, please. Everybody look at the board. Am I integrating or am I just plugging in?
Plugging in.
Okay.
Okay, because I'm letting the weaker kids think they have to integrate every problem. No, I just need f of 3 minus f of -1. Where's the integration? The integration's vanished because I'm using net change. Did everybody understand that? The problem began life as an integral, but I observe there's a mismatch, therefore I have to use a net change. I'm using the net change, and I have to just do f of 3 minus f of -1. And there's no integration anymore. Okay, let's do f of 3. What's 3 squared?
9.
9. Is that cos
3 pi.
3 pi? Now I'm doing mental math, so we can move along. Cos of 3 pi is -1.
Is
Is that
Negative
-9 then?
Mhm.
And then we're finding f of -1. -1 square,
1.
1.
1.
Is that cos of -pi?
Yes.
Now cos of -pi is also -1. So is that -1?
Yes.
And then final step, are we just plugging in? Is that -9 minus -1?
Negative 9.
Yes.
Negative 8.
negative 8.
Was that stupidly simple?
Yes.
Did
Yes.
everybody get it? Now, before we leave, look at the problem. So they gave us f of x, and they asked for the integral of f dash, and we observed there's a mismatch. Therefore, we apply the net change theorem. Did everybody get that?
Yes.
If it was not a mismatch, look at the board so you understand this. Assume, draw skull. Assume the question said -1 to 3 f of x dx. Okay, write this down. We'll not do it. I'm just showing you, so you understand this. Okay, look here, and look here. Is there a mismatch?
No.
No.
No. Is there any reason to use the net change theorem?
No.
No. Can I just plug that in and integrate? Does everybody get that? I'll just plug it in and integrate. And we're done. Okay. All right, copy on the next problem. We're on page 24. Guys, I need more and more of you to unmute yourselves. If you're sitting muted, then you're not able to answer questions. Okay, copy on the problem. Okay, next. Look here and look here. Do not speak. I'm giving you 5 seconds. I need everybody to answer the question in their minds. It says F, and they give you F dash. Is there a mismatch? Yes or no? Do not speak. Think it in your head. Okay, I'm asking for this. I'm giving you this. Is there a mismatch? Yes or no? Miss Ramirez, yes or no? Is there a mismatch?
No. Yes.
No, there is a mismatch. I'm asking for F and I'm giving you F dash. Okay, some students have trouble with this concept of mismatch. If I said F of X, if I'd given you F of X, is there a mismatch? I'm asking for this, I'm giving you this. Is there a mismatch?
No.
No, there's no mismatch there. But if they ask, if they ask for F of -1 minus F of 2 and they give you F dash, is there a mismatch? Yes or
Yeah.
no?
Yes.
Yeah. So if there is a mismatch, are we using net change?
Yes.
Yes, if there's a mismatch, we are using. Okay, smart kids, do this yourselves. Give me the other side. What do you write on this side? Hint, apply the net change here.
Negative. Identical.
Integral.
Integral from, smart kids, slow down. Which is the lower limit?
Negative
2.
1.
Okay, the kid who said 2 is
Oh, 2.
correct.
2. Yeah,
Because
2.
is the negative guy with the 2? Ah, do you see it was confusing? Isn't it tempting? Look at the board. Is it tempting to write -1 at the bottom?
Yes.
Yes.
Yes, but the negative guy, okay,
Is
so
the
this
one
is,
in front.
yeah, the bottom guy is the negative and the top guy is -1. Is that F dash of X?
Yeah.
Is it clear? Is it tempting, once again, just to make sure, is it tempting to write F of X dx? It's tempting, but is it incorrect? That's not how net change works. is the integral. Okay, now stop. Can we now, at this stage, just plug in f dash? They gave you f dash, correct?
Yeah.
And now I'm plugging in ex minus 3x dx. Now stop. Now in this question, is it obvious we have to integrate?
Yes.
Yes.
Because you see an integration symbol. Because I'm showing you, scroll up please, go to the previous problem. In the previous problem, remember, we applied the net change theorem and we got f of 3 minus f of negative 1, and we just had to plug it in, correct? There was no integration involved. Does everybody understand that? But in this question, on the right-hand side, when we plug in f dash, we have an integral symbol. So we have to integrate. Do you see that? Because a common confusion students have on the first day is, Rama, I don't know when to integrate. Do you see an integration symbol? Then integrate. Okay, what's the integral of ex?
EX.
Yes.
Ex. What's the integral of 3x?
3x squared
Over 2. Lower limit,
2
2.
upper limit.
negative 1.
Negative 1.
Okay, can we move on? Can we move on?
Ram, I have a question for.
Yes, go on.
So, for the function that says like f dash of x, like can we set it equal of like f negative 1 equals to e of x, so we don't have to do all of that?
What?
Like, I'm
No, Mr. Gurbani, here's your confusion. When you see the original question, they say f of negative 1, f of 2, but I don't have f. I can't plug anything in. There's a mismatch. You see that? When you have a mismatch, you immediately have to apply the net change theorem. You can't plug it in. I'm not giving you f of x.
no. Like my thing was like, okay, f dash of x is like f of like a minus f of b, so it couldn't be like f of a equals to e of x and f of b equals to t of x. Then you can combine those two and set it equal to each other.
But I have no idea what you meant. Okay, ask me later. Ask me later.
Okay.
Okay. Guys, go to page 25, please.
26.
Is that 26? Yeah, 26. Thank you. Okay, I'm showing you what to look for. Look here and look here. Think before you answer. It's not a trick question. Is there a mismatch?
Yeah.
Yes.
Yes.
Yeah.
So should we apply net change?
Yes.
Okay, I'm blowing your minds. Everybody, what's the integral of f double dash going to be? Which smart fellow will tell me what the integral of f double dash is going to
F dash.
be? Is that f dash? Is everybody okay there? Now, should we apply the upper limit? Is that f dash of pi
Yeah.
minus
F dash of pi over
f dash of
Over two.
pi over 2?
Yeah.
Now stop. Have they given us f of x?
Yes.
Yes.
Then I easily find f dash.
Yes.
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 So f dash, guys, we're finding slopes. Repeat, we're doing slopes, not integrals. What's the slope of sine x?
Cos X.
Minus, what's the slope of cos x?
Negative sin X.
Negative sine x. Absolute last step. Can I now plug in f dash of pi and then
Yes.
f dash of pi over 2 and then subtract them? Did everybody understand how this problem worked?
Yes.
Okay, now I'm just doing mental math. Cos of pi is negative 1, sine of pi is 0. Cos of pi over 2 is 0, sine of pi over 2 is 1. And then final step, I'll plug it in. So that's negative 1 minus 1, which is negative 2. So once again, the big part of the lesson is this. If you see a mismatch, then you apply net change. If there is no mismatch, then just take the ball and run. You just plug it in. Okay. Okay, copy it on the function. We're on page 27, please. Everybody, we're on page 27. Okay, first step, interpret the question exactly the way it's written. Okay, how do we interpret? Guys, do not overthink. Show every step is no in Ms. Chawla. Okay, it says find the average acceleration. So how do we always do average of anything?
AV.
AV, very good. Equals 1 over
2.
integral
0 to 2.
A of t dt.
dt.
Is everybody okay there? First step. Okay, now stop. Look at what I'm doing. Is there a mismatch? Yes or no?
Yeah.
Yes.
Okay, it's not a trick question. I need integral of a of t, and I have v of t. Is there a mismatch? Yes or no?
Yes.
Yes. Miss
Yes.
Yes. Should we apply the net change?
Mm-hmm.
Yes. Can I apply the net change as it is, or I've got to rewrite something? What smart kids? We did a lesson 10 minutes ago. I can rewrite a of t as
V dash
V
T.
dash of t.
v dash of t. It's gonna apply the net change now, which just becomes
V of V of
We have 2.
2
v of
minus
2 minus
V of
v of 0. Ah, do I know the velocity function?
K.
Can I just totally plug it in now? Okay, now think before you answer. I'm not asking a trick question. Is there any integration involved in this problem?
No.
No.
No, there is no integration. We went from the integral to a difference. There is no integration involved. Do you see that? Okay, sidebar. Can I plug in v of 2?
Yes.
Okay, what's 2 squared?
4.
Times 3
12.
12.
minus 2 plus 1,
3.
3 is a minus 2/3,
Yes.
which is 34/3.
Yes.
Mm-hmm.
V of 0, 3 times 0
0.
0.
0.
is at negative 2 over 1.
Negative
Mm-hmm.
2.
Negative 2.
This is negative 2. And absolute last step, should we just plug it in?
Yes.
Guys, don't forget the 1/2, yes?
Mhm.
V of 2, which is 34/3 minus negative 2, correct?
Mhm.
Can we finish the problem?
Yes.
So once again, does everybody understand the concept of mismatch and when to use the net change? Okay, if there is a mismatch, you're applying the net change. If you have to integrate, you'll integrate. If you don't have to integrate, you're not integrating. You're not doing something because you feel like it. You're going where the problem leads. Okay, let's do another problem. Okay, smart kids, see if you can do 3 steps yourselves. The more steps you do yourselves, the better off you'll be. See if you can set it up. Do as many steps as possible yourselves.
Sure.
First step, I'm guiding you. First step, interpret the problem the way it is written. It says average velocity. So what are we writing on the left-hand side?
AV equals
AV equals
0.
1 over 5
1 of 5.
times integral from 0 to 5 v of t dt.
V of t. Interpret it exactly the way it's written. Stop. Next step.
V of t is S dash of
Stop. Is there a mismatch?
Yeah.
yes.
Yes. You need to ask yourself that question. Is there a mismatch?
Mm-hmm.
Yes.
Yes.
Okay, write the next step yourselves. Write the next 2 steps yourselves. Look down. Write the next 2 steps yourselves. Okay, Ms. Ramirez, we can write V of t as
S dash of T.
very smart. So what is your last step? So 1 over 5.
Yeah. V of no S of 5 minus S of 0.
Stop, everybody. Is there any integration involved?
No.
No.
No. Are we just plugging in S of 5 and S of 0?
Yes.
Yes.
Are more students getting comfortable with this?
Sort of.
Yes.
Yeah.
Yeah. Miss Andelkovic, how are you doing?
Pretty good.
Pretty good. Mr. Manasra, Mr. Al-Nabulsi, how are you guys doing?
Good.
Okay, we'll skip this. We'll do this problem. Copy down page 30, please. Okay, I want you on your notebook to write this down. Okay, in your notebook, write that down, please.
I'm sick for.
Okay, smart kids. I'll give you 3 options, choose wisely. Is that average rate of change? Is that average? Or is that net change?
Average.
Is that average rate of change? From first semester, what am I writing on the left-hand side?
MSEC.
MSEC.
MSEC. Is that just average rate of change of the velocity function? I'm going to write something on the board, see if you're okay, and say, yeah, I get it. Is that just V of 4 minus V of 2 over 4 minus 2? Is everybody okay there? I just interpreted the question exactly the way it's written. Does anybody have any questions?
No.
Okay, now stop. Is it a mismatch? Everybody look at the board. Do not speak yet. Give it 5 seconds. Look at the numerator. Look at what's given. Is there a mismatch?
Yes.
Yes, they're not the same function. Therefore, should I apply net change?
Yes.
Yes. Okay, I'm going to help you. Is that integral? Remember, if I have a difference, I go to the integral. If I have an integral, I go to the difference. What's your lower limit?
2.
2. What's your upper limit?
4.
4. Now I'm going to jog your memory. See if you're okay with that. Will that become v dash of t?
Yes.
Isn't that net change? Is it tempting to write v of t though?
Mhm.
Yes. Is it tempting to write v of t? No, but it's v dash. Oh, what do we know v dash as?
A of t.
A of t. And do we have a of t? And we have a of t. Have a look. We're given a of t. And then all over. What's 4 minus 2? Guys, do not forget the denominator. All over
2.
2. Okay, now stop. Look at the board, please. Can I write the denominator as 1/2?
Yeah.
Yes.
Okay, I'm moving the 1 over 2 like that. Is that just integral, big brackets, 2 to 4? Is that just t minus 1 whole square? Okay, now think before you answer. I'm not asking a trick question. It is not a trick question. Does this problem involve integration?
Yes.
Yes.
Yes, because you see an integral symbol. You see an integral symbol, you integrate. If you do not see an integral symbol after net change, then do not integrate. Okay, just to make sure everybody gets it. Look at the previous page again, please. Everybody, look at the previous page. We applied net change, we got this. Look at the board. Is there any integration involved here?
No.
No, there's nothing to integrate. I'm informing you what are the weaker student sources of confusion. So one thing is, Rama, when do I use net change? If there is a mismatch, you apply net change. Second, Rama, when do I know how to integrate? Over here, there's no integration involved after applying net change. We know S of t, we're just doing S of I minus S of 0. Over here, after applying net change, I see an integral symbol. So I have to integrate. Okay, let's do integrals for practice. Okay, smart kids, can I use the power rule? That's a linear function. Let's apply the power rule. So it becomes t minus 1 to the power of
3.
over
3.
3 or 1/3. Lower limit,
2.
2.
upper limit.
4.
4.
Can we move on?
Yes.
Yes.
Okay. Let's do another one. We're on page 31, please. Okay, smart kids, I'm giving you a huge tip. You have to write down notes to yourself. Often, so, okay. Let's go. Okay. What's the first question I'm asking myself?
Is there a mismatch?
Very smart. Thank you. Love you, Bellarmino. Is there a mismatch?
Yes.
Okay. Do the next 2 steps yourselves. Hint, do some rewriting and give me a right-hand side. We can write A of t as
V dash of t.
V dash.
V dash of t. What should I not forget to bring down?
1 over
A
3.
third
1 over 3. That can vanish. What's your right-hand side?
V of 4.
V
Minus.
minus
Year
1.
1.
Stop. Now, does it involve integration or just plugging in?
Just
Plugging
plug
in.
Plugging in. Is everybody okay there?
Yes.
After you do net change, there's no integration symbol. There's nothing to integrate. We just have to plug it in. Okay. Now let's do the interpretation. So I'm going to assume in your homework you can plug in 4 and plug in 1, simplify, plug it in. Okay. Next, let's interpret. Look at the board, please. Look at the board. Look at the original question. I'll give you 3 options. Choose wisely. It is not a trick question. Choose wisely. Is that a net change? Is that the average rate of change? Or is it the average of?
Average.
The average.
Is that
Average.
average formula? Okay, interpret it literally. So that is the average. Okay, now here's where some of the weaker kids get confused. Look at that function. It is the average of
Acceleration.
acceleration. It is the average acceleration of the object over,
1 to 4.
1 to
thank
4.
you, 1 to 4. Now I'm blowing your minds. Everybody look at the board. I'm blowing your minds. Okay, now look at this expression. Look at that expression. Guys, which of those three formulas it reminds you of? I'll give you three options. Everybody stop what you're doing, look at the board. I'm showing you two ways to interpret it. Does it remind you? Look at the right-hand side. Does this remind you of average, net change, or average rate of change?
Average rate of
Is that remind you of, look at the board. Is that like V of 4 minus V of 1 over 4 minus 1? Do you see that?
Yes.
Yeah.
Mind blown. So we can also write this as average rate of change.
of acceleration.
No, stop. Let me help you. Because the weaker kids get confused. Of which function?
Velocity.
The velocity function. Don't freak out. What is the function there? Is the average rate of change of the velocity function of the object over
1 to 4.
1 to 4. It's that easy. There are two interpretations. So you look at the original question and say, hey, what does that guy remind you of? Okay, before we leave, I looked at the original question and said, hey, that's the average of the acceleration function. And I looked at the right-hand side and I said, wait a second, that looks like MSEC formula. It's the average rate of change of the V function, velocity function. Okay, I'm wrapping up the lesson. Okay, let's do some examples on net change corollary. Okay, now these are just, I'll do more of these examples on what's it called? Office hours. Go down to page.
Take infinity.
Okay. There you go. Page 52, please. Or you can just look at the board. Just look at the board. We're wrapping it up. Okay. Now look at the board, please. These are questions on net change corollary. So I'm showing you how we need to use net change corollary. So you make a note to yourselves. You will use the net change corollary if you're given a starting value, say f of monkey equals donkey, and you're given f dash. Okay. That's how you know we will use the net change corollary. Is that clear? Okay, in this question, have they given us f dash? Have they given us a starting value?
Yes.
Yeah.
And they're asking for another value, correct? So I will set it up. So f of 0 equals, now play along. Now use the starting value, f of 1 plus integral, memorize the pattern. This is a net change corollary. Okay, hint, what's your lower limit? We went over this. Is your lower limit going to be 1 or lower limit going to be 0?
1.
1, very good. That guy is a lower limit. And the upper limit will be 0. Is that clear? Okay, you'd be tempted to write f, but it's actually f dash. Is that clear?
Yes.
And that's the net change corollary. Everybody, smart kids, stare at the board, memorize that pattern. The starting value plus starting value to ending value, and then f dash. Okay, is f of 1 given to me?
Yeah.
Is a -2
Yes.
plus integral 1 to 0. Is f dash given to us?
Yes.
Yes.
3x squared minus 4x. Is everybody okay there? Can we just integrate? It's an integration symbol. Can we just integrate?
Yeah.
So bring down the -2. Guys, bring down the -2. Okay, what's the integral of 3 and then x squared?
X cubed.
3x cubed over 3.
Divided by
Is everybody okay there? What's the integral of 4x?
Minus 4.
negative 2x.
2x squared.
Or -2x squared? Lower limit,
1.
1.
upper limit?
0.
Okay, let's actually do this. So you say, okay, that's stupidly simple. -2 plus, what's 0 cube?
0.
0.
0. So is the upper limit just 0 minus 0? Yes.
Yes.
Minus, what's 1 cube?
1.
1.
Minus 2?
Yes.
Yes.
Yes. And then last step,
Negative.
don't forget to bring down the 2. And what's negative of -1?
1.
So is final answer -1? Okay, was that stupidly simple?
Yes.
Sort of.
Okay, let's do another example using net change corollary. We're on page 54. We're almost done. We're almost done. And guys, I'm pleading with you. We lost time with the stupid computer. This thing. Please attend office hours. We'll do far more examples. You leave comfortable and happy.
What page is this?
Sorry, we're on page 54.
Thank you.
Okay, so copy down this. Okay, I'm going to translate this into calculus notation. It says find the position at t equal to 3. So what do they really want? What symbol do I use? I need the position at t equal to 3.
S of 3.
S.
Thank you, S of 3. Okay, that's the question. And the question says the position at t equal to 1 is negative 4. So S of
1 equals
One.
negative
1
4.
equals negative 4. Is everybody okay there? Now, helping you make connections. Have they given us a starting value? Yes?
Yes.
Yes.
As a
Have they
one.
given us its derivative?
Yes.
Yeah.
So should you use net change corollary then?
Yes.
So look at the board so you observe the connection. So S of 3, the ending value, equals S of 1 plus, take the ball and run.
Integral from 1
Integral
to
from
3.
1 to 3. Is that going to be S dash?
Yes.
Do you see the connection? Ooh, but what do we know S dash as?
V of t.
And is that V of t given to us?
Mm-hmm.
Yes.
Do you see the connection? Now S of 1 was given to be negative 4, correct? Is that just 3t square minus 2t square? Oh, by the way, that was 2t. That was a typo. That's supposed to be 2t. Now, is that problem easy to solve?
Yes.
Yes.
Okay, last question of the day. We will only set it up. We'll only set it up. We're on page 55, please. Okay, we'll only set it up. Copy that down. Okay, I want to see learning happen. Make connections. What am I writing on my notebook? It says, find its velocity at t equals 3. So what are they asking for?
V of 3 pi over 2.
Thank you. V of 3 pi over 2. Question mark. That's what I need. And they say, if its velocity at pi over 2 is 3.
V of
V
pi.
of pi over 2 equals 3.
Okay, once again, have they given us a starting value?
Yes.
Look at the board. Look at the board. Have they given us a starting value?
Mm-hmm.
Have they given its derivative?
Yes.
Yes.
Can we use the net change corollary? See if you can write this down yourself. So V of 3 pi over 2 equals, see if you can write the right-hand side all by yourselves. Hint, use the starting value plus integral, fill in the blanks on the right-hand side. I want to see learning happen. Okay, go.
We are
V of
pi
3 pi over 2.
V of pi over 2.
Integral
Plus-
from pi over 2.
No, guys, don't forget to write plus.
Pi over
Read
2.
the,
Plus
get the
pi over
plus.
2.
Lower limit, pi over 2. Upper limit.
Pi
3
over
pi over 2. V dash.
Very good. V dash. I need that step shown. Don't switch to A immediately. V dash of t dt. And then can we cross out V dash of t and write it as
A of
A
t.
of t.
A of t? And do we know A of t?
Yes.
Yes.
Okay, and you can integrate. Now V of pi over 2 is given to be 3 plus integral pi over 2 to 3 pi over 2. A of t is given to be 4 cos 3t. Whew. Okay, put your pencils down.